Hello, I'm Poughon, a PhD student in collaboration with the biorobotics team of the Institute of Movement Science in Marseille. Biorobotics means that we want to take inspiration from nature to build better artificial systems. Here we want to mimic a small desert ant, able to do homing in a desert environment without GPS. Years ago, researchers showed that these ants were able to leave their nest, foraging in the search for food, then coming straight back to the nest by doing path integration. Sun rises at the east and sets at the west. By knowing the local time, we can know where the sun is in the sky, and thus deduce how we are oriented toward the sun and get our heading, like with a compass. The scattered light from the sky have a typical polarization pattern that allows us to know where the sun is, even when hidden behind, for example, a building. These ants use this pattern to estimate their hiding while walking. Can we use this idea to improve the localization of future autonomous cars? GNSS systems, like the GPS, have a degraded accuracy in some situations, or may be jammed. Merging the data from different sensors can be a way to overcome this issue. To measure the sun position, we can measure skylight polarization by passing the light through polarizer, in this example by matching the 4-dot intensity pattern of the polarizer at the bottom with the printed pattern at the center. We can find the sun direction. The ISM lab previously built a small robot and bot able to navigate like the ant, but its compass couldn't be directly adapted on a car because it used slow rotating polarizer prone to mechanical failure with time. Another way is to use a division of focal plane camera that have integrated on-chip micropolarizers to be sensible at the same time to the color and to the polarization. When we add fisheye lens, we are able to measure polarization over a wide field of view. In the first step, we are characterizing the skylight polarization with this camera in regard with the weather degradation and accumulate data over long term to evaluate the potential availability of the sensor. In the other way, measuring skylight polarization on board a car may additionally help us to get the weather condition. This is the kind of data we are obtaining. On top, our simple physical model, on bottom, our measurement. These divisions of focal plane camera are useful to scientific use, but their cost is still too high for mass market application. In the second step, we are developing a disruptive low-cost sensor based on a consumer-grade camera. Here, we turn the defect of an optical component, called a waveplate, to our advantage. Depending on the light incidence angle, the properties of the waveplate vary, creating interference fringe that depend on the polarization pattern. A patent has been filed about this work. Previously acquired data will help us in the design of the sensor. We are currently operating ground-based tests with a motorized telescope mount to compare sensor output with ground truth. Finally, we will mount our visual compass on board a card prototype for evaluating the potential of this technology in this application. Thank you for your attention. Please feel free to ask any question you may have.